Welcome to Maths Buster, presented to you by Codelites Academy. Let us start with a new typical Codelites Academy. So the question that we are solving today is of typical question again of differentiation. The dy by dx, where your y is x squared plus 3x plus 5, the whole cube. Okay, let us start quickly with this question. So this term which we see here is your polynomial function. Can I say that? Yes. This is your polynomial function. This cube is your power function. Okay. Now, which function is applied on which, or which function acts as input for another? You might have seen our earlier videos. So I have explained you what input means, what main function, what terms we are using, just simply for us, so we can easily solve this chain rule based derivative questions. So see, this cube is getting applied on this polynomial function, or polynomial function acts as an input parameter for your power function. Okay, so power function is your main function. Okay, our main function means first we'll be considering that function in your chain rule. Okay, now means power function means which? From our standard derivative formulas. Okay, so these are our standard formulas of derivatives. So this formula sheets you can refer. So here we can see x raised to n is n into x raised to n minus 1. Okay, x raised to n means what I can say it as variable raised to constant. Can I say n is your constant? Okay, for a particular question n is your constant. So is this a variable full polynomial? Yes. And is 3 your constant? Yes. We can use this. So we will start differentiating d by dx of whole question again. Correct. Whole question we note down raised to 3. So what is the differentiation? N into. So n is your 3 into x raised to n minus 1. What is your x? Or here we can say this is your input for your power function. So that input, full total input we will write x square plus 3x plus 5 raised to n minus 1. 3 minus 1, 2. Now is it completed? No. We will differentiate what now? Yes, the input we will differentiate. So d by dx of x square plus 3x plus 5. So on the next line, 3 into x square plus 3x plus 5 whole square. This will be as it is, because it is already differentiated. Nothing to do now with these terms. Just simply carry it in your next step. Now you are differentiating this. This is your polynomial. Again, we can write this as u, this as v, this as w. So simply we can take each term's derivative u, v and w separately, and we can add them. Okay. Derivative of x square. Yes. 2 will come down. X raised to 2 minus 1, 2x. Derivative of 3x constant into a variable, where we have that result. Okay. Here you can check This is your derivative of c into u, which is constant comes out and remaining is derivative of your function u. So 3 will come out and derivative of x, which is obviously 1. This you need to remember. Derivative of x is 1 and derivative of constant. So see, you can observe here derivative of constant is 0. This is 0. Still chain rule will apply. So here we can apply the chain rule here only. And here we will not apply because nothing is left. X also we have differentiated. Your last thing is x raised to 1. Okay. Last element which we are differentiating in your derivatives entire chapter will be obviously x raised to 1, because after differentiating x raised to 1 it is 1 and this is the last input. Power is your 1, so power function is getting applied on x input. Now after differentiating this x input there is no another input remaining or no another function anything remaining, so we end here. But here after taking derivative of x square, what was your input for square? X. So I will differentiate x here, so it will be d by dx of x. But d by dx of x with respect to x is also 1, is only 1. So your result will remain same, x square plus 3x plus 5 the whole square, correct, x square this is plus 5 into 2x plus 3. Okay, because this is your 1, this is your final result. You can also join our Maths Buster WhatsApp community to post your questions and engage in mathematical discussions. To get these formula sheets by our academy, you can click on the drive link, Google Drive link present in the description, from where you can easily download them. Also, if you want any of your typical questions to be solved, you can email us at the email ID provided. Okay, we will conclude this session.